The laws of chemical combinations created ripples in the stagnant pool of chemistry. They enabled scientists to carry out various experiments that helped in forming strong foundations in chemistry. However, the laws still needed experimental evidences and proofs. Only then would they be accepted. It was around the first decade of the 19th century that a chemist and a physicist from England named John Dalton was successful in answering many questions. He proposed a theory which was then known as the Dalton's atomic theory. With this theory, many concepts regarding matter, composition of matter, atoms, and even combinations of atoms resulting in compounds were better understood. Okay, let's first take a very quick look at the 6 major postulates of his theory. First, he said that all matter is made up of very tiny particles called atoms. Secondly, he suggested that atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. Third postulate was, atoms of a given element are identical in mass and chemical properties. Similarly, fourth postulate was that atoms of different elements have different masses and chemical properties. Fifth postulate stated that atoms combine in a ratio of small whole numbers to form compounds. And lastly, the relative number and kinds of atoms are constant in a given compound. I know I just rattled off the postulates. Don't worry, let us now understand each postulate one by one by taking the same example of elements A and B giving rise to compound C. The first point stated that all matter is made up of very tiny particles called atoms. It means that when we go on dividing matter into smaller and smaller sections, what we get at the end is atoms. So can we say that elements A and B are made up of atoms? Yes, in fact, compound C is also made up of atoms that have combined together. So the first postulate was very easy to understand. The second postulate was that atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. Now, what do we mean by this? Yes, it means that atoms are like the fundamental units. Dividing them further is not possible. Also, in a chemical reaction, atoms may combine together to form new units. However, no new atoms can be created and existing ones cannot be destroyed. So in this case, the atoms of element A and B are just combining to form compound C. So can we say that no new atoms are formed in this case? Yes, and similarly, no atom is destroyed. Let's move on to the third one now. The third postulate states that atoms of a given element are identical in mass and chemical properties. If we zoom into the element A, we find all the atoms that make up element A are just the same. And in what sense are these same? The atoms have identical mass as well as chemical properties. In simple words, the third postulate states that all atoms of a given element are identical. And does this explain the fourth postulate too? Yes. The fourth postulate states that atoms of different elements have different masses and chemical properties. So are we able to notice that atoms in element A are different from those in element B? Absolutely. And in what sense are they different? Atoms in element A and B have different masses and even different chemical properties. In simple words, it states that atoms of different elements are different. The fifth postulate states that atoms combine in a ratio of small whole numbers to form compounds. Now, what do we mean by this? In this chemical reaction, we find elements A and B reacting and giving us the compound C. If we observe well, a unit of compound C has 2 atoms of element A and 1 atom of element B, right? So aren't these whole numbers? Yes, this means that in any compound, the elements are always present in a ratio which comprises of whole numbers. You will not find half or 3/4 atom combining with the other. In case of water, we always have 2 hydrogen atoms and 1 oxygen atom combining to form 1 unit. In 1 unit of carbon dioxide, we have 1 carbon and 2 oxygen atoms. The same holds true for all compounds. The number of atoms of a particular element in a compound will always be a whole number. Now for the last one. The sixth postulate states that the relative number and kinds of atoms are constant in a given compound. The same explanation that compound C has 2 atoms of element A and 1 of element B makes us understand this. Yes, if we scan compound C, we will always find 2 atoms of element A and 1 atom of element B in a single unit. And this is applicable for all compounds. We've already looked at 2 examples, water and carbon dioxide. In case of 1 unit of water, we always have 2 hydrogen atoms and 1 oxygen atom. And in a single unit of carbon dioxide, we have 1 carbon and 2 oxygen atoms. Carbon monoxide has 1 atom of each, that is carbon and oxygen. While 1 unit of ammonia always has 1 nitrogen atom bound to 3 hydrogen atoms. So the number of atoms will always be constant in a unit of a particular compound. In a nutshell, all these postulates help chemists to further understand behaviors of elements and the compounds formed from them. But for understanding these elements and compounds, knowing the concept of atoms is necessary. Let's get to know what exactly these atoms are, how they exist, their mass, and many such interesting concepts in the upcoming videos.